We want to work on every day. We're going to improve our accuracy of our method. All right, so the rectangular method is what the Greeks used. It's what they started with because they didn't have a concept of calculus yet. This was how they were estimating the area. So each day, we're going to kind of take baby steps towards improving our accuracy. We'll use both geometry and technology to do that. So that's what we're going to do today. Yesterday, we kind of talked about the idea of maybe averaging as being a way that we could improve it, but we're going to talk about 2 other ways to do that today. I don't know why I have stripes down my screen, but we'll see. So you will need your calculators today. We're going to use that program we loaded yesterday. So remember yesterday we talked about how RAM has pros and cons, and how one way that RAM is always going to produce either an overestimate or an underestimate or part of both, depending on how the concavity and the direction of the graph would go. So you would need to be able to be comfortable writing an explanation. It will be an overestimate because, similar to, when did we do that before?
With the concavity and...
Like we did it with the line, right? The linearization, it's either skimming across or it's skimming underneath, and it will be an overestimate because, and so you'd need to have a calculus reason, which would be based on the direction of the graph, so increasing or decreasing, and the concavity of the graph, and help you. And if you have some of both, you just say, well, more of the graph is behaving in this way. So you need to be comfortable doing that. So today we're going to introduce the idea of MRAM. So you had LRAM and RRAM. So what do you think M stands for?
Midway.
Okay, the middle or the mid, which is not the same as the average. It is a common misconception to think that the midpoint is an average, but that's not true. The only time that would be true is if we were dealing with linear functions. Linear functions, because they have a constant slope, then the midpoint is the average of the left and the right. But with anything that has a curve to it, anything with concavity, the middle is not the same as the average of the left and the right point. It's its own distinct point. But it does give us a better accuracy. So I'm going to zoom in a little bit. Look what happens to those rectangles when we put the middle of the rectangle on the function. Instead of the left corner and the right corner, we put the middle. What happens there? What do you see? It's both. Every rectangle is both above and below. You have sections that are above, which is causing you to overestimate, but at the same time, you have sections that are below, gaps. And so the over balances out the under, and you have a better estimate. So we're going to go for hitting the middle of our rectangle on the function rather than just the left corner or the right corner. And this is going to be a way that we get even better accuracy. All right. So we're going to start with, and based on my instructions at the top, MRAM sub 3, we're going to be only doing 3 intervals for starters. Okay, we talked yesterday. What's another way of improving our accuracy? More intervals, but we're going to start with 3. Okay, 3 for starters. All right, so our intervals, all right, oops. Let me get back to that. All right, so go ahead and we divide this into 3 intervals. We're going to be doing it right on the whole numbers, 0, 1, 2, and 3. Okay, our 3 intervals. But we want the center of the rectangle. So we're not going to be using the left corner, and we're not going to be using the right corner. We want the center of our rectangle to be determining the height of where we're going to be. All right, so let's go to the very center. The very center of this whole graph is happening at what number? Which is 1.5. All right, so let's go to 1.5, and let's mark that off right here. And that point is going to form our first rectangle. And part of that is going to be under, and part of it is going to be over. So it's going to look like this, straight across. And you can see that part of that rectangle is over the curve, and part of the rectangle is under the curve. What is the area of that center middle rectangle? Okay, what is its base from side to side? 1. What is its height? Read your table. Okay, where did we find the height? At what point? Okay, we're finding the height right here at the very middle. We're finding the height at 1.5. And so this is a height of 3.75. So with a base of 1 and a height of 3.75, this has an area of 3.75. And now we'll go on either side, and we'll find the center of each of those, the middle, and then we'll find the height there. So let's do the bigger one. Let's do the one on the right-hand side. Okay, where is the center of that one going to be? 2.5. Okay, according to the chart, so I'm going to put that dot here. And according to the chart, how high is that?
6.75.
Okay, so that height there is 6.75. And so that rectangle, again, is partially above and partially below. So with a base of 1 and a height, we have an area nicely of 6.75. Our last one, the smallest one, is going to be centered, the middle, over 0.5. And how high will that one be? Okay, that's 2.75. But what do you notice about that rectangle? Okay, it's both symmetrical sides of that are both underneath. So whereas the other two are gonna like cancel out the over under, this one has 2 unders. So overall, this estimate is gonna underestimate because of that, the way that third one is going. And that's gonna be 2.75. So the value of our MRAM 3 is going to be 2.75 plus 3.75 plus 6.75. And we add those up and we'll have our value. So let's see, that's 650, 12, 25? 13, 25?
Yeah.
13.25. But we still would say 13.25, which is more accurate than what we had yesterday with our LRAM and our RRAM, but still going to be an overall underestimate because of that, the way that first rectangle is behaving. Okay, any questions on that? Okay, so just to summarize, what is MRAM not?
An average.
Okay, MRAM is not an average of LRAM and RRAM. Unless, what would the only instance be? Okay, if it was a linear function. Okay, if the slope was constant. So why not?
Because it has curve.
Okay, because the slope is not constant. All right, because the slope is not constant. If the slope was constant, it would be a linear function. And then that's the only instance when LRAM and RRAM would truly be an average of an MRAM. Okay, so MRAM is the most accurate rectangular approximation. Now, there's going to be other kinds of approximations also, but this is the most accurate of the ones of the rectangles. Okay, so next slide. Same function. How can we improve again? Well, we already know that MRAM is the best method, so how can we improve upon the method? More rectangles. Okay, so now I'm going to ask you to do MRAM 6. So we're going to do that together. So this time you'll be doing 6 of these. So go ahead, and so now we're going to be doing them on the 0.5s. I know that last one didn't turn out very nice. Now, you don't have to start in the middle. I just happened to start in the middle last time. You can do these from left to right or right to left or however you want. So let's start with this first one here. What's the middle of that?
0.25.
It's 0.25. So the middle of that is right here. Now, is 0.25 on your table of values? No. All right. So how can I figure out how high that is? I did give you an equation. And so the equation is actually the parabola, x squared minus x plus 3. So the quickest way to do that is to put that into your y1. So go ahead and put that into y1. All right, so we've got x squared minus x plus 3. And then we want to find out what the value of 0.25 is. So there's a couple ways you can do that. You can go to a home screen and use VARs to do that. Okay, that would be one way. So if you quit this, went to a home screen, used your VARs key, pulled up y1, and then in parentheses put 0.25 after it. So that would be one way. Go to your VARs. Select y1 as your vars, in parentheses, put 0.25, and what do you guys get?
2.8125.
Yeah, 2.8125. That rectangle there is partially above and partially below. What is the area of that rectangle? But remember how wide the base is. Okay, what's our base this time, which is different than last time? Last time the base was how long? 1. This time the base is only 0.5. Okay, yes, we're above 0.25, but the full length of the base from end to end of the whole rectangle is 0.5. So what is the overall area for that one, given its base and its height? 1.40625 is the full area, which is partially under and partially over. Yeah.
How far do you want this to run?
Okay, great. If this has a terminal value like this, okay, take all the decimals you can. If it's a repeating, if it's irrational and it's going on, then you have to go to at least 3. Okay, but these are terminal, which means they end nicely in a 2-5. All right, where would then having trouble with finding your vars?
Yeah.
Okay, Christian, you know how to show her? Okay. All right, now we're going to need to do this again. The next rectangle, where is its height found?
0.75.
It's found at 0.75. Okay, remember, this is above 0.25. This is above 0.75. Its height, what do you think? Is exactly the same. Okay, based on symmetry, it is exactly the same as the other one. Also, 2.8125 for a total area of 1.40625. Okay, the next one. Its middle, because we're doing a midpoint, is above the value 1.25. Okay, how can we find the height at 1.25? Again, you can go back to your vars and you can change the value to 1.25. Now, do you have to do that every time? Can anybody think of a different way rather than using vars every single time, which is fine? What? You could do graph and trace. Any other way?
Can you adjust your table?
Yes, you can adjust your table. That's probably what I would do. Okay, I'm just going to adjust my table. I would make a table, and the table is going to be set to the 0.25s. So that I can check 0.25 here, and I can check 0.75 here, and 1.25. So you can totally adjust your table and check that as well. Okay, so go to your table set. That's going to be second window. And have your table start at what number? What was the first one we wanted to know? 0.25. Have your table start at 0.25. And then what was the next one we wanted to know?
0.75.
0.75. How far away is that?
0.5.
0.5. And the next one is how far away is that? 0.5. So you can set your table to change every 0.5. So that would be your it's a tiny little triangle that stands for the Greek letter delta. Okay, delta table. And so you'd make that 0.5. So if you're starting your table at 0.25 and then delta changing your table 0.5, and then you can look at your table. Okay, and so looking at the table is second graph. And now that table has all the values for you. You can just pull them right off of the table. So I think that would probably be how I would do it. But there are several ways. Tracing on a graph is fine. Using VARs is fine. But what do we get for 1.25? What's our value there?
3.3125.
Okay. The height is what does it say? 3125. So what is the area? If the height is 3.3125, what's the actual area? 1.65625. And we keep doing this. Use the height from the table. The next one would be 1.75. Okay, and the height is going to go here. The height at 1.75 is 4.3125. So then the total area will be 2 point, what do we get, 6 point what? 6.0125, okay? Oh, wait. Say it again, Christian.
2.1565.
All right, and then we're gonna do rectangle 5 and rectangle 6 using the same strategy, and then add them up. All right, so I'm gonna I'm gonna pause the recording. So do you have to have a graph? And the answer is no. Okay, we don't need to have a graph. We can do this from a table. All right, so if we're using, this is the same table we had yesterday. If we're doing MRAM, how many intervals could we create from the table that we are given in this last question? Okay, how many intervals can we create from, and this is all we have. We don't have an equation, we don't have a function, this is it. How many intervals can we create? Okay, what's the first interval?
0 to 7.
Okay, 0 to 7, what's your middle value then? What's the value associated with 3.5? Oh, shoot. You can't get 3.5 off this value, so I don't think you can do 0 to 7. What can you do? I can do 0 to 12. And even though, what would normally be the middle of that? 6, but we don't have 6. What do we have? 7. That's as best as we can get. All right, so my MRAM, how many can I create? I can only do 3. So the MRAM 3 is going to have a base interval that goes from 0 to 12. So that's 12. Times a height interval using the middle value, and what's that going to be?
36.
That's going to be of 36, so it'll be 12 times 36. What's the next one I can create from where to where?
12 to 26.
12 to 26. So what's the base interval from 12 to 26? 14. From 12 to 26, I believe, is 14. Okay, and then what's the middle value, or the best middle value I have?
48.
Okay, the middle would be 48. And then plus, and my last one is going to go from 26 to 35. What's that interval? Okay, 9 times the middle value of 40. And that'll be how we calculate MRAM. What are the units going to be if we're multiplying the time interval, which is in seconds, and the velocity value, which is in feet per second? Okay, my answer needs to be in feet because we are multiplying the interval of time times the midpoint value of the velocity. So once you multiply and add, then you'll have the total feet traveled by the car over this interval of time, okay? So unless you have a function, you only can work with the data that you're given, all right? Don't try and create data if you don't have it.